0.2 molar enthalpies. What is the molar enthalpy? So look at this reaction. H2, 1 mole of hydrogen gas reacting with half mole of oxygen gas give you water, 1 mole of water, and some energy release. So 1 mole of hydrogen gas, when it burns, produce 241.8 kilojoule. Means molar enthalpy for hydrogen burning is 241.8. Molar means for 1 mole of your reactant, the amount of the energy released for 1 mole of your reactant. Okay. When there is exothermic means heat is produced, then the molar enthalpy or the energy released will be negative. For endothermic, when the energy is absorbed, the delta H molar enthalpy will be positive, like that. H2O liquid, it turned to the gas, so it needs energy to vaporize, right? It's going to be endothermic. When the energy is appearing on left side, it would be endothermic. So the delta H for this vaporization is going to be 40.8 kilojoule per mole. Why we say kilojoule per mole? Because 1 mole of that needs 40.8 kilojoule. This is just molar enthalpy. Okay, so just remember that the enthalpy of the system, delta H, is equal to and the number of mole multiplied by molar enthalpy. So the enthalpy is equal to N, the number of the mole multiplied by molar enthalpy. Molar enthalpy, the energy released for 1 mole. If I want to find the energy released for N mole, I have to multiply by N, right? Let's just do an example. A common refrigerant has a molar mass of 120.91, is ferron. Is vaporized. This results in energy being transferred from the inside to the outside. The molar enthalpy of the vaporization is 34.99 kilojoule per mole. If 500 grams of the refrigerant is vaporized, what is the expected enthalpy? So we want to find enthalpy, right? So the thing is that I know the molar enthalpy. The delta H, here is mole multiplied by the molar enthalpy. I know the molar enthalpy, which is 34.9, so I know that. But I need to convert 500 grams into the mole. Since I know the molar mass, so just mass, so N is equal to mass over the molar mass. 500 divided by 120.91 will give me 4.35. So mole is N is 4.35. Multiplied by molar enthalpy will give me the enthalpy of the system. Okay, there is another example. What amount of ethylene glycol would vaporize while absorbing 200 kilojoule of heat? So you need to know the molar enthalpy of vaporization of the ethylene glycol is 58.8 kilojoule per mole. Knowing the heat released is 200 kilojoule, we can find N. Delta H is N delta H. The rearranging for N is going to be delta H over molar enthalpy, and you just substitute the number, you will get that. Mole is 3.4. So you can do question number 1, 2, and 3. Now, calorimetry, physical changes. So look at this calorimetry. We have a reaction, we have a chemical. You put in a water, and you have a thermometer. You have an isolated cup, so these are the, let's say, plastic. The heat cannot escape easily from that. You can look at the temperature. The temperature is rising in your thermometer, and you can measure the change in temperature. You can identify the initial and final temperature after reaction. So the temperature of the water is rising, right? So knowing that the heat capacity of the water is 4.18 joule per gram degree Celsius, we can look at this question to understand it better. In a calorimetry experiment, 7.46 gram of potassium chloride is dissolved in 100 milliliter of water. You have 100 milliliter of, we can turn it to the gram. It's going to be 100 gram of water. Initial temperature is 24.1 and final temperature is 20. Make sure this final initial temperature is going to be for water, because your system is going to be water. The temperature of the water will rise and fall. So the delta T I have mass of that, I have heat capacity of water. I can find how much heat was transferred using Q is equal to MC delta T, right? I'm gonna say, just put that Q is gonna be MC delta T. What is happening here? This is the energy that absorbed by water will be the same as energy released. The delta H is the energy released by what? By your solution, which is potassium chloride, right? So Q is delta H. As you see, they put it. It's dissolving. The heat released by that is the heat absorbed by water. I know that Q is MC delta T, and the delta H here is N multiplied by delta HX. Here is molar enthalpy. I'm looking for the molar enthalpy. Do I have N? N is the amount of the mole of the potassium chloride you have. So 7.46, we divided by molar mass to get the mole. So you have N. So you have N, you have change in temperature, you have the molar, and you have heat capacity of water, you have the mass of the water. You just need to rearrange it for delta H. So the delta H, the molar enthalpy, is MC delta T divided by N. And when you do that, you can get the answer. So let's just see the next question. Let me erase that. So what mass of lithium chloride must have dissolved in a temperature of 200? If the temperature of 200 grams of the water increased by 6, increased by that means your delta T is 6. Here is the mass of the water. We know the heat capacity of the water is 4.18. The molar enthalpy of the solution is negative 37. So again, we know the Q of the water is N multiplied by delta H of the solution. We have delta H of the solution is 37, right? Q is MC delta T, we have N, we have C, we have delta T. Here, we have delta H, you just bring it to the other side, go to the denominator. We can calculate for N is the mole of lithium chloride. Then knowing N is mass, multiply the molar mass, just look at the table, find the molar mass of chloride, lithium chloride. So the M will be mole multiply the molar mass. Here the molar mass is 42.4, multiply the mole that you got here, you get 5.7 grams. Now you can do question 4 and 5.